So today we are going to see logistic regression. In the earlier video, we have completed our linear regression model and it's how to check if the linear regression model is performing well or not. So that we have completed and other also videos are completed. So this is the first problem means which this is the first classification problem which we are going to see. And with respect to classification problem, this is the first model which we are going to see. So in this video, we are going to see all these questions answered. So what is the classification problem? In the logistic regression only, I have written all these questions which we are going to cover. So this question which we'll be seeing is this: what is the classification problem? This is the first question which we'll be going to answer. And why not use linear regression? This is the second question I will be covering. And third question, logistic regression and algorithm. So how the logistic regression algorithm works, this we will be seeing in this video. And one more question, which is what is decision boundary? With respect to logistic regression, it is coming. So we will be seeing that. And this how to check model performance. This I will be taking a separate video and I will be uh, making a separate video on the checking the model performance of a classification problem. So I will be making a separate video for that. So in this video, only first four question answer we will be seeing. First, second, third, fourth. So let's start. Logistic regression is one of the basic and popular algorithm to solve a classification problem. Whenever classification problem comes, so this is the first algorithm, which is the basic and the first algorithm which comes in the minds of any of the machine learning engineer or data scientist is logistic regression. It is named logistic regression because its underlying technique is quite the same as linear regression. Its working and its working is same like a linear regression. That is why the name is logistic regression. Only the difference is in the starting word, which is in the linear regression, there was a linear word, and over here it is logistic, and rest the other things are same over here. It is, I will say, 60 to 70%. This algorithm is same like a linear regression. Only 10 to 20% difference is there, which we are going to see in this video. The term logistic is taken from a logit function that is used in this method for classification. So how the word logistic came? Because of this function, logit function. As this logit function is used in this model, that is why its name is given logistic. Logit, and so from here only this name has came, logistic regression. The working will be same like the regression model only, but only logistic function is used, so logistic regression name is given. So this was a little bit intro, and let's now deep dive into what is classification problem, and let's understand by an example. Okay, so let's move on to the what is classification problem. We identify the problem as a classification problem when independent variables are continuous in nature. Independent variables, which we have discussed, like x1, x2, so these two are independent variables. and this is dependent variable. When x1 and x2 are continuous in nature, when the numbers are like in continuous form. Suppose your IQ is there, x1, your x2, in x2 there is CGPA. So these two features value are in a continuous form. So it could be like 10. CGPA could be in the range of 1 to 10, so 6.83 suppose, and here 1 means the student has got placed. So IQ is there, CGPA is given, and the student will be get the placement or not, that is written. And suppose your one more data point is there, like 6 is over here, and your IQ is 4.3, and your he didn't got placed, so 0. So 1 represent the student got placed, and 0 he didn't got placed. So this is the classification problem. So these x1 and x2 are in continuous form, 10, 6.8. So this is a number which is in a continuous form, continuous nature. Okay. Let's see. And the dependent variable is in a categorical form. Categorical form is this are category. This the student will be placed or he will be not placed. Okay. So this is a category. The real life example of classification example would be categories the mail as spam or not spam. Suppose we are getting emails from the other persons or companies, okay, and our our mail is working whenever the mail is genuine and it is coming from some person which is a genuine person and he has mailed us, so that spam, that mail should be as a not spam because it has been came from a genuine person. And if suppose the mail has been came from a any of from a fraudulent person, the mail has came, and so the our mail should function and it should classify that mail into a spam or not spam. So this is the real world problem where there is two class. The mail can be spam also and it cannot be a spam also. So these two possibilities are there. So this is the classification problem. One more example is given over here. To categorize the tumor as malignant or benign, whether the person is having malignant tumor or a benign tumor. So these are also the two categories. A real world example which is given. First was the spam, not spam, and malignant if a person is having malignant or a benign tumor. And third, which is transaction is fraudulent or genuine. So these type of examples you can give in your classification problem while you are explaining to other person, and you can give 2-3 examples so that the other person or an interviewer is able to understand that you are knowing the what is classification problem and what are all the examples coming in it. So let's now go to the next point. All these problem answers are in a categorical form, yes or no. So which we saw, yes or no, like the student will be placed or not. So yes or no. So these two class were there. So that is why it is called as classification problem. So I hope you guys have understood what is classification problem, and let's check out this image. So like we saw the example of classification problem. Email can be spam also, or it cannot be a spam also. So this is a classification problem. Then we saw tumor. Person can have malignant tumor, or he or she can have benign tumor. So these two are the classes. So classification problem. Example, your transaction can be fraudulent or not fraudulent or genuine. So you can give the labels like it. These all are the positive class or these are negative class. And labeling you can give on your problem, means on which class of importance do you are solving in the model. So by that you can give the labels. Suppose I want to give spam as a positive class, so I will be labeling it as a positive class, and not spam, I will be labeling as a negative class. For the model, while building the model, while writing code, you have to change these labels into numbers, because the model can't understand the words. So he only understand model or machine only understand numbers. So we have to change these words into numerical form. So you can give any number over here. You can give spam as 0 also and not spam as 1. But over here I have shown you spam as 1 and not spam as 0. So it is up to you. You can give any number to your class. And same for these two examples. So these three are the example of classification problem. You can take any of the problem where there is two classes are coming. So it is coming in the binary classification. Binary means two class are there and we have to classify that. So this comes into binary classification. So logistic regression is able to perform binary classification very easily. This model is made to answer the data points which are having data points which are this model can be this model is mainly used for the binary classification purpose. For multi-class classification purpose, you have to go to some other model. For multi-class classification, you have to go to some other model. But binary, if your problem statement is to classify binary classification is there, so you can work and you can use this as your main model, logistic regression, because logistic regression works very well on the binary classification. Okay, let's move on to the next question. If the linear regression and logistic regression, if the linear regression is same, so why can't we use linear regression only for this binary classification problem? So that the question is. So let's see. Suppose we have a data of tumor size and its malignancy. Here the data points are tumor size and your malignancy. The patient is having malignant tumor, yes or no. These are the, suppose the data is there. As it is a classification problem, yeah, we have to classify it. If we plot, we see all the values will lie on 1 and 0. Yeah, because the y is not in a continuous form. It is in a classic. It is in a class form, and labels could be 0 and 1, binary classification. So data points will be lying on 0 and 1, and in middle there will be no data points. Okay, so if we are building a best fit line, so this is our linear regression line. By assuming the threshold of 0.5, we can do line pretty reasonable job. So by this you can see, by keeping the threshold at 0.5, so over here, if the data points are here, means near 0, means it is less, it is less than 0.5, so you can say it is correct and our model is giving us correct predictions. And if the data points are above 0.5, so all the data points are above 0.5 only, so this is all one class. These all data points are coming in the class 1. So it was performing well in this type of data. Let's see. But after sometimes we will be seeing that linear regression cannot be used properly in a classification problem. So as we will be moving further in this video, you will be able to understand why you can't use linear regression on this classification problem. So now let's see. We can decide the point on the x-axis from where all the values lie to its left side are considered as a negative class. The data points which are on the left side are the negative class. So tumor size, these data points are negative. Okay, so if we are plotting it on the graph, so the data points which are lying on the left hand side, you can easily say that they are coming in the 0th class. And the data points which are on the right hand side, you can easily say like they are in the first class, in the class 1. So here also it is working properly. That what we can see over here. Okay. But the problem starts when the data is not clean or it is a noisy data. When we get a noisy data or when we are having outliers in our data set, then our linear regression can't perform classification problem. Its accuracy goes down very badly and it is not working properly. So the researchers and scientists came with a new model which was which was the name logistic regression. Logistic regression is same like a linear regression only that we discussed. Let's see what will happen when the outlier will come in this data point. So what all problems the linear regression will face. But what if there is an outlier in the data? So in this data points, which is marked as a cross, these all are the data points, and this cross is a outlier. And for building a linear regression line, as we all know, these all data point will be considered and the best fit line will be drawn. That is what our linear regression is. So, but what here it is showing that if we fit the best found regression line, so yeah, we have fitted this blue line, that is a regression line. It still won't be enough to decide any point by which we can differentiate class. It will put some positive class example into negative class. So as you can see over here, these all data points are classified properly as negative. So this first class is not, this is showing as a positive class because this line is down. So I will be drawing and showing you. So this according to the linear regression model, this is negative class. Okay. And according to the linear regression, this region says that it is a positive class. So it is able to classify these all data points correctly. But over here, this data point, it is unable to classify. So it is not working that good. And over here also, this was the originally it was in class 1, but our model told the linear regression model that it is in negative class. So here this linear regression, we can see it is making wrong predictions. So that we don't want. We want accurate result. That is why we can't use linear regression in the classification problem. I hope you guys have understood. Okay. So to make accurate predictions, we came up with the new algorithm, which was logistic regression. Let's read this. It will put some positive class example to negative class. The green dotted line is the decision boundary. The green dotted line, this is the decision boundary. It is dividing malignant tumor from benign tumor, but the line should have been at a yellow line, which is clearly dividing the positive and negative class. So the example which I gave, that is also correct. And here one more they have written that I will be discussing. According to this, the threshold, it is taken as 0.5. If the tumor size is less than 0.5, then it is a negative class. That's what they are telling. It is same like what I told, but in a different manner. Okay. So what this is saying, that this all comes in a negative class, and this comes in a positive class. So two scenarios we have seen. If this linear regression line, this below is, let's say it is a negative and it is a positive, our model says. So because of that, it is predicting wrongly. And when the threshold is taken like 0.5, if the numbers are less than 0.5, tumor size is less than 0.5, then it is negative. And if the number is coming greater than 0.5, then it is a positive class. So in both the scenarios, you can see it is making lots of wrong prediction. Okay. This line, it is telling, the model is telling that on the left hand side, the negative class are there, and on the right hand side, positive class is there. But the line should be this yellow line, which our linear regression is not working. Okay. So yellow line, which is clearly dividing the positive and negative class. Yes, you can see these these are the positives and these are the negatives. So by yellow line, you can easily divide the positive and negative class. But our linear regression line is drawing this type of line. And if the threshold is kept, like tumor size is, when the tumor size is less than 0.5 or is equal to, then it should be negative, what it is telling. So in both the scenarios which we saw, it is making wrong predictions. And this yellow line is what? It is a correct line which can be drawn, and it is also classifying them into 0 and 1. So that 0 line only, which we will be drawing with the help of logistic regression, that we will be seeing in this video. So just a single outlier is distributing the whole linear regression prediction. Because of this single outlier, the linear regression is not working properly over this type of classification problem. So that is why, to make a correct predictions every time when the binary classification is there, the scientists and the researchers came with a new model, which was logistic regression. Okay. And I also want to say you guys that when the classes and 0 and 1 are can be classified with the help of, means the class 0 and class 1 should have a separate, they should be separated from a single line. If they are not that much mixed, like the positive and negative class are mixed, if the data points are like that, then you can't perform logistic regression. If the classes 0 and 1 are easily separable by one line, then only you can use logistic regression. That is also one of the assumptions. Like if the data points are separable when you are plotting it, so you can apply logistic regression. And if the data points are not, they are like the 0 and 1 class are mixed and they are can't be separated by a single line, so it will be not giving you the correct predictions. So you have to just go on and use some other model, decision tree or some other model you have to use, but logistic regression, it will not give you an good results. So this was the one more information that I wanted to give related to logistic regression. Now let's see how is the logistic regression is working and how it is different with the linear regression. As discussed earlier, to deal with outlier, the logistic regression uses the sigmoid function. In the starting, we have read the first line, which was saying over here, it was there. I will be showing you once again so that you can recall. The term logistic is taken from a logit function. So this was the line which we discussed earlier. Okay. So logistic regression uses the sigmoid function. So logistic regression uses a sigmoid function. As explanation of logistic regression can begin with the explanation of a standard logistic function. The logistic function is a sigmoid function that takes any real value between 0 and 1 and it is defined as. Because of sigmoid function only, the values which we were getting in a linear regression as a continuous y values, now we will be getting the values in a range of 0 to 1. Okay, with the help of sigmoid function only, we are able to achieve the continuous numbers are in a range of 0 to 1. So you have to keep in mind this sigmoid function in the logistic regression, that which is very much important. Okay, let's see the standard logistic function. So this is the formula. Okay, how it is denoted by formula. So sigma of t is equal to e raised to t divided by e raised to t plus 1. So it can be written like this: 1 divided by 1 plus e raised to minus t. And if we plot the graph, okay, if this we will be plotting on a graph, so you can see a S curve. In linear regression, we were seeing the straight line, but because of sigmoid function, we are able to see graph is in a S curve. Okay. With the help of sigmoid function, we are able to classify all the data points. So these little changes we have done, the researchers have done, and they have seen it is working properly on the binary classification problem. Okay, I will be discussing in more detail here. Let's consider t as a linear function in a univariate regression model. We know this is our t is equal to beta 0 plus beta 1 x. This is our linear regression equation. Okay, and here, as I have written also, what it denotes to recall you, like beta 0 is the intercept, okay, and beta 1 is the coefficient or a slope, and x is the independent variable and t is your dependent variable, which is why we have to find out. So this we on in place of t, which is this minus t, you can see In place of minus t, I will be substituting beta 0 plus beta 1 x over here. See, the same equation is there, but on the place of t, I have substituted beta 0 plus beta 1 x. So this will become as a logistic equation. Okay. So if someone is asking you what is the equation of logistic equation, so you have to say 1 divided by 1 plus e raised to minus in bracket beta 0 beta 1 x. So this is the logistic equation. So with the help of this sigmoid function, it is taking the outlier also into consideration, and it is classifying outliers also correctly with the help of this model, which is logistic regression. As you can see over here, this is our outlier. Okay. So this is our outlier, and because of sigmoid function, we can see the curve will be not straight, but it will be in a S shape. So here it is in a S shape. And these are the data points which is zero, means these all data points are in the zero class, and these all are in the first class. So with the help of this S curve, we are able to classify all the data points which are of two classes. So with the help of sigmoid function, we are able to achieve good result on a binary classification. Okay, let's move further. But sometime it will shift its y-axis to left. This is our x-axis. This is our y-axis. So with the outliers, it will be shifting our y-axis. So this line can be extended over the left hand side also, and right hand side also. So this can be happening when the logistic regression is building this S curve. Okay. Decision boundary. What is decision boundary? Decision boundary, you can see over here. Decision boundary is the line which is separating the two classes. So in a simple words, I have explained you, but we will be reading this and also seeing the graph so that you guys also understand it in a easy and in a simple manner. Decision boundary helps to differentiate possibilities into positive class and negative class. Linear regression boundary. Linear decision boundary. So you can see over here, these data points are zero at a zero class, and these are all first class data points. So we can separate it by drawing a single line. So by this line, we are easily able to separate these two classes. So this line is only called linear decision boundary. It is very easy, guys. You can also understand. Very easy. Only the names are little bigger and difficult. But if you will deep dive into this model, so it will be not that much difficult, as we are able to see over here. So let's see this graph once again. For y is equal to 1, equation of the line would be x1 plus x2 greater than equal to 3. If the x1, this is our x1 and this is our x2. Okay. X1 and x2 is greater than 3 or 3. So this 3 and greater than 3 means here all these all data points, these all should be 1. Okay. So I am showing you how to read this. Okay, guys. So, and if the equation of the line would be x1 plus x2 is less than 3. Less than 3 means this all. So this side it is first class data points and your zero class. So with the help of linear decision boundary, we are able to classify the data points into 0 and 1. When the data points were linearly separable, then we can, just by drawing a linear decision boundary, we can separate the two classes. That's what it is written over here. Okay. Now let's move ahead. There is also non-linear decision boundary. When the data points are non-linearly separable, then what? Then there will be not a linear line, because over here linear line will be not giving us accurate result. It will make lots of mistakes. So to avoid mistakes, we are drawing a circular decision boundary. So over here you can see this inside, means inside this circle you can see that it is a zeroth class, and outside the circle all the data points which are coming, which are so let's see this equation x1 square plus x2 square is greater than equal to 1. So x1 square means this full area x1 square, and x2 square is this, so this full. Okay, this full, and here also full, but it is told greater than equal to 1. 1 is over here and greater than and equal to, so this whole area, okay, this whole area 1 and greater than 1. Okay, so 1 greater than 1, this all area, whenever any data points will come, then it will be your y class, means your first class it will be. Okay, and when for the zero class, x1 square plus x2 square means this whole x1 and x2, okay, is less than. So less than means till here. So this whole area, whenever any data points will come, so it will be as a zeroth class. So this is how you can read this equation. Okay. So by the help of circular decision boundary, we are able to classify the data points as a 1 class or a 0 class. So with the help of decision boundary, you can do that. Okay, so this was the logistic regression which we have seen, and I will be telling that it is not that much difficult. If you are facing little bit difficulty, so I will be suggesting you to go through the video once again and see it properly and read all the sentences and the formulas and the graph and once more time, and you will be able to understand it properly. And if you have understood this logistic regression model, so please hit a like button and also subscribe my channel, and also hit the bell icon, guys, to be notified whenever I am uploading a new video, so that you can get the notification when I upload a new video. So we'll meet you in the next video. We will be seeing the how to check the performance of the logistic regression model. So till then, bye bye, take care, and happy learning.